Good morning. Here, as I have declared in the last lecture, that in the next lecture, I will give some real life example of control system. Normally, already we have familiar with the two control system terminology. One is known as open loop system, and that is known as closed loop system. So here we will give one or two examples of open loop system as well as the closed loop system. First of all, we will try with the open loop system. Open loop system means what is the basic block diagram? We know this is your input command signal. This goes to your system, and system gives you some output signal. And here a reference signal point is set, right? So this is the basic block diagram. Already we know. Now with respect to this, we are taking one example of open loop control system that is normally used in our daily life, that is known as the toaster. So this is the structure of the toaster. What happens in case of toaster? This is the set point selector, right? And these are the two gaps you see where you can insert the bread. And whenever you want to get the toasted bread, so what is your input and what should be your output? That is to be determined first from any system. And what is the reference point, signal point? That is to be set point. That is known as set point. What is that? First of all, this is our system. So what we want to get as the input? What should be our input? Input is some darkness knob. Here you can set the timer corresponding to the darkness of the bread. Why it is called the open loop, that I am going to discuss in detail. So first of all, there is a knob known as darkness. Say anyone wants to get the lower darkness, anyone wants to get the medium darkness, anyone wants to get the high darkness. So according to that, some timer button is there. You may put the timer as 1 minute, 2 minute and 3 minute, depending upon your choice of darkness. So what should be the output? Output is this is your input. So this is your input parameter. So whenever you are going to design any control system, or for practical system, you want to get whether this system is having some, what are the different kinds of input and what are the different kinds of output. So what is the output of this system you should get? That is the crispness, or you can better call it darkness. That means if the darkness is desired to be in certain way, such that this is most crisp, the toasted bread you can get. So actually what happens now, I am going to tell you that if you say for example a bread is taken here, and you set the darkness knob and the timer is adjusted at say 1 minute, so it also gives you certain kind of darkness or crispness. Now what happens? Maybe some kind of disturbance coming, because what happens, the company or the producer of the bread is not same in all this, or the thickness of the bread is not same all this, and according to that the quality of the bread also is not same in all this. So what happens, if you just fix the 1 minute time to the toaster actually what gives you certain kind of darkness corresponding to the timer that is actually set within this system. So what happens, you get certain kind of crispness, but once the crispness is not at your desired value, you cannot change this 1 minute time, because it is already set. That is the reference point selector. So what happens, you are giving some input, say 1 minute, and this toaster will give you crispness, certain darkness. That darkness may not be acceptable to you, or you may not be feel happy with that kind of darkness or crispness. Maybe it requires some extra time to give you more darkness. Maybe it has to be taken less time to give you your desired specifications. So what happens? Actually, what is the amount of crispness it is making here that is not conveyed to the input to control the knob. So that is your problem with the open loop system. So that is the real life example of open loop system. Another open loop system is, I can say, is washing machine. Second example is washing machine. Daily life you can have this in use. So, but what is the functionalities of the washing machine? Why this is open loop system? That has to be clarified by you only, and that is one assignment after this time. And you have to identify what is the input parameter, what is the output parameter, and how this is one open loop system. Why this is called the open loop control system like this? So if there is no feedback from closed loop path, sorry, output to input, so that is the your open loop control system. If there is for example, if this type of toaster is designed in such a way every time it measures the crispness, if that is possible, and this gives you signal to the input such that that desired crispness is not reached, so you have to give more time, or the crispness has been already achieved, so you have to just switch off this toaster or like that. In that case also this could be used as the closed loop system, right? So this is an example of open loop system. Now I am going to discuss one more example of closed loop control system. Yes, this is the example of closed loop control system. See, this is the block diagram I have written here. What is this? This is basically AC, one kind of air condition, right? Actually, what happens in case of any room temperature control system? Basically, this is room temperature control system, right? So, what is this? This is your room, and this should be perfectly insulated. As in case of air conditioner, I have already in the previous lecture discussed some part of this, that whenever any disturbance signal comes, then to adjust the output to get the desired value, it is very difficult. So that kind of signal is known as the disturbance signal. What is the disturbance signal in this case, and what are the input and output parameters? And according to the generalized block diagram, how this can be interpreted, that I am going to show you. Yeah, what happens? See, this is your actual room, and actual room temperature is set, say for example 22 degrees centigrade, and this is one gas fire, one kind of burner which produces gas due to heating effect, and this is thermocouple or thermometer, whatever, that is inserted in the room. What happens? And this is the heat loss, and this is where you get the outside temperature. This is your outside temperature. Now this is perfectly insulated. That is the actually balanced condition, and that is one of the most important condition that is to be followed, because when this temperature, this is the feedback part, right? This goes to the controller, and you see, if you can just relate between this block diagram, generalized block diagram, and this system, you see this is your desired temperature, this is your desired temperature, and this temperature is normally converted by using some potentiometer into voltage. And this controller, this is again one thermometer which senses the input temperature of this room, and this room temperature is sensed by some feedback sensor, and using this sensor this is converted into voltage. So you get voltage 1, this is your desired, and this is your room temperature. So this is, I can say it, VD is the voltage you want to get, and this is your reference voltage. If there is any difference between these two, so controller takes actions, and that controller gives some signal, some actuator. Here when gas, this I can say it, gas solenoid valve is there, which can move up and down linearly, right? So if it moves up and down linearly, corresponding to that, what happens? This path opens or closes, right? say this one, this is the storage of the gas. Storage of the gas, when more amount of gas is to be passed here, then definitely this gas fire stove will pass more amount of gas to balance the temperature in the room, right? And if the temperature is lower than the desired value, definitely this is lower and this is higher, so there is again one error. So this error is corrected by either P, PI, PID, different kinds of controller I already discussed. So according to that, they will take action and they will generate one control action. Control action goes to the actuator part. And actuator means some mechanical device that may be actuated by some signal. That signal come here, and this is a gas solenoid valve. By using this spring action, this solenoid valve will up and down. If this goes down, that means this path is closed. When this path is closed, so no gas will be given to the gas stove and no gas will be given to this room to lower the temperature. So according to this displacement of it through the actuator. So actually in our control system block, what you get? We get input, right? We get the input. We get the error block, right? We get the controller. We get actuator. This is solenoid valve, and actuator actually actuates the plant. How it actuates the plant? Either it gives more gases or stop producing the gases through it. So it goes to the plant, and plant output is your desired temperature. Now this temperature is sensed by another temperature sensor, that is thermometer, and this gives you some voltage here. And as these PID controller, all the controller types whatever available in the market, they works normally on the voltage. So every kind of sensors output, maybe level, maybe temperature, maybe flow, maybe pressure, whatever, that must have to be converted with the voltage by using sufficient conversion instruments. So according to that, this is a closed loop system, because you get every time, every instant of time, you get from the sitting in the input side, you are getting the information of the output. So that is the way how you have to get the different elements identified as input elements, input signal, command signal. This is controller output, actuator. Then this is known as the manipulated variable, and then goes to the plant. This is our system, and this is your temperature, that is the output, that is the desired temperature value, right? So this is one example of closed loop control system. And there are control system in the process. We get the level controller. uh, so as the assignment, I can say you another closed loop control system, that is the level control system in process plant. So how the level control system in the process plant is taking place, so that you have to understand, and you have to write your answer in your assignment copy, such that you can also get habituated to get the information regarding this overall control system block diagram, where input is given and how the controller is taking place, taking action, and based on this action, how this actuator actuates the plant, such that you get the desired output. Whenever input is getting changed, accordingly you will get the output at the desired value through this closed loop control system, right? So it's the time to conclude the chapter. That means till this time what we have learned, and based on that, what are the different questions coming in my mind, and you have to solve these questions. And first of all, classify the control system. Identify the parameters related to level control of any process industry. Third one, why negative feedback is used in control system. Okay, these are the basic questions, and you just go through the lectures and try to understand what is this and what classify. I am just giving the hints. Classify the control system means based upon the feedback system, you know whether this system is open loop control system, whether this is a closed loop control system. And once you classify the system, definitely there should be some example, practical real life example of open loop control system as well as the closed loop control system. Next part is that identify the parameters related to the level control of any process industry. So first of all, you have to get the block diagram of level control of any process industry. Next, from that, you have to identify what is the input variable, what is the output variable, what is the controller output, why, which place the controller is taking place, and what is the kind of actuator here you are using to control the level of any process plant. Next, what is the negative feedback used in control system? That is a very important question, and you see, to make the difference between open loop control system and closed loop control system, what is the major part, who is taking the major part? That is the feedback path. That means from input to output, signal goes, and output to input also signal coming. So that is the feedback path, and this feedback may be here, but we are making this is a negative feedback, right? Very important. Why it's not the positive feedback? What is the consequences of using the negative feedback? If the positive feedback is used, normally you see here I can give an example of positive feedback, that is oscillator. You know what is the oscillator? Oscillator means certain frequency, certain amplitude, some output is oscillating between the two amplitude, that means two interval or magnitude, right? So that can be obtained with the help of positive feedback. Barkhausen criteria, right? So that is not in desired in our control system. Whatever we will talk about is all about the negative feedback. So negative feedback is having certain advantages regarding, first of all, stability, second one sensitivity, third one gain and bandwidth, that is the frequency response analysis. So these are the basic points you need to careful, and you have to write these questions, that is answer of this question of the assignment. Now in that next lecture I'll be discussing about the mathematical modeling and why the mathematical modeling is so important, and how the mathematical modeling of the different systems are done, and what are the precautions to be taken in that case. Okay, thank you.